Swayam Prabha. Digital India. Educated India.
Welcome back. So in the last class we discussed about potentiometers. Potentiometer as a angle sensor we studied, and then we also saw how Hall effect sensor works. It is a very versatile sensor, you know now. So it can be used like a digital sensor for detecting a proximity, or it can also be used as an analog sensor like the example that I gave you, where it can be used like a tilt sensor. We also saw how to obtain velocity using potentiometer, which is an analog output sensor, and using a standard quadrature encoder also, where it is a digital in nature and you can get number of counts per second. You can express it as velocity. You saw how a tachometer can be used as a velocity sensor, or a dedicated encoder interface, which is a device, industrial device, which can take input from optical encoders, incremental encoders, and it can give you velocity automatically. So these are few that we learnt in the last class, moving along sensors. So today further, now that you already are familiar with obtaining velocity, let us see if you can obtain acceleration also. Okay, so we'll discuss about acceleration sensor today, especially MEMS type of sensor, micro electromechanical system, and AC based sensor, alternating current based sensor, especially resolvers and synchros. Okay, so yes, let us move ahead. So yes, acceleration sensor, basically MEMS based and using force sensor also. I'll tell you how it can be used. A force sensor can be used as an acceleration sensor. So here is the basic principle of standard MEMS accelerometer. So it's a basic physics. I tell you how it is. So yes, this is a comb drive, which is commonly known as comb drive. When you have a suspended mass that is blue in color over here, this is a suspended mass which is floating in space. It's a free space where it can move, it can oscillate, and it is supported by a beam like structure which is over here. Okay, so this is the beam on which whole of this mass is hanging. So there are two beams which are fixed here. There are two beams which are fixed here. So you hope you can understand the structure. A mass which is suspended like a simply supported beam at two ends, and it can oscillate. If you give a longitudinal oscillation like this, it will oscillate. Okay, so these are like springs. These are like springs with stiffness K. Let us say this proof mass, this mass is known as a proof mass. So this is of mass M, let us say. Now having some structure which is permanently mounted on the ground. Okay, so these yellow ones are permanently mounted structure which is on the ground. Not on the ground actually, that also is made up of silicon wafer cut out. Okay, so a part of silicon wafer is remaining on the surface, that is not moving, and other part is suspended on a simply supported beam. Okay, so yes, so overall this structure is like a comb drive where you have two different combs which are inserted one into the other, and that can oscillate. So one of them is stationary, other one can move. It is a floating structure. Okay, so the stiffness of this structure, the floating structure on which it is hanging, is simply supported hang, is K. A is the acceleration, let us say I give to whole of the system. Whole of the system, let us say it moves by an acceleration A. So in that case, the mass blue in color will experience a force which is like this. Okay, it will experience a force which is like this. So that is a pseudo force that it can see, and that will tend to bend this simply supported beam. Okay, so the mass new structure will be something like this. This is your mass M. Okay, this was initially hung like this. Okay, so now when whole of this structure is moving with an acceleration A, so this is the situation. So this whole of the comb drive which was there along, that also moves. Okay, so there were some intermediate fingers which are inserted here. Okay, but they are stationary. They are stationary. They are not moving. Okay, so what is moving is this blue one which is here. Okay, so now how it is constructed, you see carefully now. So you have two capacitors which are made out of it. One of them is here, that is between the yellow ones, these fingers, fixed fingers, and the moving finger. So this is the space which is behaving like a capacitor. You have yet another capacitor which is hanging here, that is C2. So this space is also for the capacitor. So it behaves like a parallel plate capacitor with dielectric in between. Okay, dielectric is air here. So it is epsilon 0 which is here. So there are two capacitance, C1 and C2. Now when this has moved by due to an acceleration A by certain distance x, okay, from the mean position, let us say it has moved by a distance x. Okay, so then the capacitance of both the parallel plate capacitor changes. Okay, so that is what is the basic principle. We have to measure the change in capacitance somehow, and we'll come to know what is the acceleration. So that is how it works. So let us move ahead. So yes, so this is the scenario here. So let us say you just have two capacitors, although there are many. One is here, other one here, here. All of them are actually added in parallel because they are in a structure, they are like that. They are like a parallel plate capacitors. So many parallel plates which are there. Okay. So yes, this is C1, this is C2. So initial distance between those two plates, let us say it was D. So when you moved along this direction, okay, by an acceleration A, x double dot. So this proof mass has moved by a distance like this. Let us say this was x. Okay, so this was x which it moved behind. So yes, so now the capacitance C1, which was initially C1 was epsilon A by D. Now D has reduced. You see this gap has reduced. So this time the capacitance is C1, that is epsilon 0 A by D minus x. And for the second one which is here, initially capacitance again for this also was epsilon 0 A by D. Now after moving, the distance has increased and this capacitance is now decreased. So effective capacitance now is epsilon 0 A by D plus x. So the total capacitance is C is equal to C1 plus C2. The total capacitance, as I told, it is in parallel, so which is seen from some connections which are made outside, is C is equal to C1 plus C2. So what happens here? So using the force balance equation, I can obtain this equation. So this is the stiffness of this proof mass on which it is suspended. So this is the spring. This was the spring which was here, which actually moved like this. So they can go flex. So stiffness is K. So K times of X. X is the displacement, is the restoring force. So what is the pseudo force which is acting due to the acceleration is M into A. So this is the equation for forces which are acting on it. They are balanced. So this is like this. So ultimately what you get is displacement X is equal to mass into acceleration by K, that is the stiffness. So what is constant? X is now a function of ma by k. K is constant, m is constant, so x is a function of acceleration. So now if you see, if you substitute that x here in both the equations for C1 and C2, what do you get? You get acceleration as a function of capacitance. Acceleration as a function of capacitance. So there is a circuit which actually can detect change in capacitance, right? You may just allow a AC current to flow through a capacitor and just try and measure the impedance. Okay, if impedance is changing, that will change the current which is flowing through it. If you have some pickup which can measure current, you can measure how much is the, you can back calculate how much was my acceleration, right? Because acceleration is now a function of c after doing all this exercise. So yes, this is how acceleration can be estimated. So what goes behind here is something like this. The circuit which you are seeing here is of 3-axis MEMS accelerometer ADXL345 made by analog devices. So I'll tell you first, let us talk about single axis sensor. So if this is a sensor, sensing element was similar to this. So you see how minutely it is constructed using photolithography techniques on a single SiO2 wafer, silicon wafer. It is fabricated using photolithography. Okay, so yes, you see these are really small one. So overall it is 10 micrometer in size, you can see. Okay, so it is very minute thing. Okay, and they are constructed like a spring. You see, these are springs. Okay, this is your comb drive which you can see here. So this is your comb drive, these are springs. Got it? So this small tiny structure is there, and then this is connected with electronics. So there are some sense electronics which is here, okay, where you have to measure the change in current or something, any value over there. You have analog to digital sensor, analog to digital sensor which is here, circuit. ADC is here, which finally converts that signal to analog value, and then you have filter to eliminate any noise which are there. Okay, and then you have buffer, 32 level first in first out buffer, and finally it is transmitted using serial input and output. It is SDA, SDO, SCL. If somebody has worked on embedded system or even Arduino, where they know it, actually this is I2C, two wire interface communication. So they work like you have a serial clock, you have a data, and that is a circular buffer kind of thing that keeps on going input and output. So that works like this. So it is master to slave communication sometimes, or sometimes it is just one-way communication like this device. You just send in the clock and you can keep reading the data which is there. So data may be in 8-bit, 9-bit like that. So normally it is 8-bit. So if at all you have to read a big value like in 16-bit, then you have to read 2 bytes or something like that. So that is how it works. So overall this device is sitting somewhere over here with some external electronics also, and now it is ready to be integrated with some other device like a PLC or a microcontroller or a PC or anything like that. This communication thing can be of various other types, not just I2C. It can just be an analog output that you can take up in your own data acquisition system and you can read that. So there are many similar devices, so which has different conversion thing inside. So that is there because it is a sensor. There is a circuit which is power management which is here. So this is how it works. Whole of this comes in a tiny chip. So you can imagine what lot of engineering that has gone in here. So it is very highly sensitive and it has low noise margin. So not much of noise it can accommodate. Okay, so but there are sensors which can measure up to 6G of accelerations, 6G, 3G, 2G, depending on different types of ADXL devices, and or this type of accelerometer you have different capacity. They are independent of temperature variation. Circuit itself has got compensation for temperature. It is compatible with multiple modes of communication. This was I2C. It can be standard serial RS232 or 485, right? So there are multiple modes of communication which is supported. There are many applications that you see here, usually for crash detection in case of car, which deploys actually airbags, okay, tightening of your seat belt. Those things are there in case of any accidents in automotive devices, okay, in case of automobiles. Okay, so consumer electronics like hard disk crash detection, like if at all your hard disk slips off from your hand, it has a automatic feature that it will park its hard disk. Those were the days when there was only hard disk with sectors, cylinders, moving heads and those kind of things. So hard disk is safe that way. So mobile phones, yes, you have screen rotation, that automatically when you rotate your screen, your text is almost straight, always made straight, so that you can view it properly. So that mechanism is working on screen rotation mechanism based on the tilt sensor which is there inside, right? Camera image stabilization, that works taking input from this. Industry, you have vibration sensor, crack detection, and definitely robots, they make use of this, right? And in aerospace, defense, definitely for navigation purpose, missile guidance, thrust detection, all these uses this type of accelerometer. Okay. Okay, so that's all for the at least MEMS based accelerometer, which are very, very sensitive. But sometimes you require to measure huge acceleration, you need to have very high amount of rigidity in your system. In those cases, you normally use force sensor based accelerometer. What you have here, let us say you have a device which is a force sensor. This is a force sensor. Okay, so it can give you an output in terms of voltage or anything that it has some force which is coming on here. So let us say this is attached now with a big mass. Okay, so this is your mass. So what will happen? Now you got it what I am going to do. What is there inside this MEMS sensor? I want to just scale it up. If I move with an acceleration in this direction, what will happen? You will experience a force on this mass. So this force will be F is equal to ma. So this is the force that is actually acting on top of this. So the output lets you know the force, and if you know the force, so acceleration is just force upon m. So this is the first principle that can, you just use simple physics, you can convert any force sensor to a acceleration sensor. Similar is the case. Let us say you have a spring. In this case you have a spring, okay, you have a mass, and maybe you have a sensor which is here which can measure the displacement. So this is displacement. Okay, so again if this is a mass, this is, I make whole of this mount move with an acceleration a, this displacement will be reduced. Okay, so distance between them, if it is x, x will be reduced. Got it? So using some external device, if you can measure this displacement, definitely you can estimate how much is your acceleration. So yes, there are many ways to measure acceleration using some primary sensor. Over here I have demonstrated how it can be used using force sensor or a displacement sensor. You can have other things also which can be used like a acceleration sensor. So let us move ahead with AC devices. So far the devices we have studied is only DC that uses a DC voltage to operate, mostly from 5 volt to 24 volt region. Nowadays you see your sports watch, they have accelerometer inside, okay, so that it can detect the number of skipping you have done, pedometer kind of thing, or yes, so all those sensors, they uses this. So in that case you see a simple lithium-ion battery is able to drive it. Okay, so yes, now talking about AC devices, it can be for position measurement or it can directly give you velocity. Two major one of them are resolver and synchro. Resolver is very common in industrial motor. I'll tell you why. Let us first understand how it works. So starting with that. So yes, internally resolvers are connected like this. It employs a single winding rotor that revolve inside fixed stator. Okay. Just look at this figure carefully. Okay, so I'll just make myself vanish now so that you can see the figure clearly. Okay, so this is it. So the bottom right corner. Okay, so this one. So what it is, it actually, let us say it has one solenoid coil which is here. Okay, it is not supplied by any external supply. Rather, it will just detect what is coming out of the stator armature which is rotating inside. So this is your armature which has a winding, over here, you see. Okay, and this carries a AC signal. Okay, and this is fed to it. So now if this one rotates, if this rotates like this, so what you see at a particular angle, maximum amount of flux that is coming out of it will be linked to this coil and this coil. Okay, so if it aligns with the top coil number 1, this one will see the maximum voltage induced because of AC which is here, So the one, if it is aligned 100%, that is the maximum amplitude of AC that will come here. If it is 90 degree, if it is like this will see 0 like. Okay, so there won't be any flux which is passing through this. So it will be almost equal to 0 voltage of AC that will be induced here. So what about this coil? This is a sinusoidal coil. In this coil, things are little different. So this sees the maximum value when it is aligned like this. Okay, armature, your armature is aligned with this. This one will see the maximum value, whereas this one will go to the minimum value. So you see there are two pickup coils which are in the stator, it is fitted. One of them is cosine winding, other one is sine winding. Okay, and armature carries the AC signal. So AC is transmitted to this using slip rings or maybe using a transformer which is here. So that is contactless in nature. Okay, so you have a coil which is like this, you have another coil like this, both are rotating about its own axis, about this axis, this is also rotating. So this coil will induce, if this carries AC, this also will carry AC signal of same frequency. Amplitude may be different, that depends on flux linkage between them. Okay, so this is how you can transmit AC from one coil to AC on the rotor. So this is your input. So output goes to the rotor. Okay, so this is your rotor. AC in the rotor induces 90 degree phase shifted voltages in the stators. If one of them, the voltage varies as V is equal to V0 cos of psi, psi is the angle which is here, other one will see V is equal to V0 sine of psi. Actually it is cos 90 degree plus psi. So that effectively gives you V0 sine psi. Okay, so that is what is the voltage that comes here. Both are AC, mind it. Okay, so this psi and AC signal is different. So AC signal is V is equal to V0, let us say it is some value V max. Okay, V max sine omega t. So this is the AC signal. So output is a AC, and due to linkage it creates a cos of psi that is generated in the cosine coil. So you see this omega, this frequency remains the same in the rotor as well as the stator coils, but what varies is the amplitude. Okay, amplitude itself has got a frequency inside, so it's a double sinusoidal thing, but this sinusoidal frequency is fixed. Okay, but the outer one, this cos psi, varies, that depends on angle psi. So what you see here, the secondary one will have a voltage which is induced like this. So this one is for sinus, so this is 1, and this is for cosine 1. So this is for cosine 1. Okay. So you see frequency in both the coil is same as well as in primary. So whatever is the frequency that comes from here, that goes here, that goes here, that goes here. So frequency remains the same. Okay. But the amplitude varies. So this varying depends on the angle psi. Okay. So you have stator primary, and stator has got two secondaries. Okay. Cosine and sine winding. Rotor is there. Rotor has a primary winding. Okay. That is there. And in the primary winding, it is transferred using the transformer which is here. Got it? So that is how it is made up of, and then you see something like this. Okay. So this is your, and you see this whole of this system, there was no slip ring. You could have transferred electricity to the armature rotating coil using slip rings, but because it is AC, a transformer can replace that, and it makes things brushless. So that is the reason it has long life. They are very, very rugged. They can be supplied with the existing power supply which is already there in your system somewhere. Okay, you don't need to convert it, rectify it, and then use it. So it is very, very simple and quite rugged. It is used mostly in the industrial AC servo motors to detect your angle. So angle can be detected based on the any single instance of both the coils. Let us say if this is the place I am seeing amplitude here, amplitude here. So a vector sum of those two amplitudes in both the direction will give you the position of your rotor. Okay, so you just have to measure the amplitude in cosine, amplitude in cosine, and this is sine, and vector sum of those should give you the direction. Got it? So this is how it works. Okay, so these are the two different waveforms which I have noted here, so that you can see a clear picture out of it. So this is how this resolver works. Similar is a device which is known as a synchro. This is an older device which used actually a simple 3-phase system instead of 2-phase. Okay, so instead of, the difference between resolver and synchro is nothing. Only difference is it is the resolver is 2-phase, whereas this one is 3-phase, which are, so you have now 3 different coils which are there. So your rotor will induce in one of them, let's say this is the input frequency omega, so this is your input one. Okay, this is the linkage which is there. VR is the rotor voltage. So VR sine omega t cos of psi. So psi is the angle of rotor which is here. Okay, so this is how it is linked. So if psi is 0 degree, so it will see the maximum amplitude. So this one, number 1, will see the maximum amplitude when psi is 0 degree. Okay, so this one will see maximum when psi is 120 degree. Okay, so this is how it works. So phase difference between all of these is like this. So 120 degree, other one is at 240 degree. Got it? So yes, I suppose if it is rotating like this, can be plus or minus over here. So this is how it works. So when it is 120 degree, this will see the maximum one. When this is 240 degree, it will see the maximum one. It is psi minus 120, psi minus 240. So K is the constant due to mutual inductance between them, and root mean square voltage. Square voltage of rotor is something like this, that will be induced. So it is finally given as this. Because it is star connected, so difference between the voltages will be transmitted out. So it is given by this, which you can understand. So yes, so this is how it works. So it is nothing but a little bit older way, because it uses a slip ring, so it has its own life. You have to change these brushes quite frequently, but yes, you could have used even a simple transformer over here also, but still it has 3 wires which is redundant. Okay. Yes, so each of the secondary coils will have unique set of amplitude in sinusoidal voltages of frequency omega for any rotor angle psi. Got it? So yes, now I am back. So you can see me. So yes, this is the waveform which is coming out of a standard synchro. So if this is your exciting voltage, so output 1 will be something like this. So if this is a sin A, next one will be sin A plus 120 degree, third one will be sin A plus 240 degree. Got it? So this is how all the outputs are. So at any instant of time, you have 1, 2, 3 amplitudes. So you can simply create vector for all those amplitudes, and finally what you will get is a rotating vector resultant, so that rotates. So you can directly calculate the resultant of all the 3 differences, and finally you can calculate the rotor angle. So this is how it works. Okay, so that's all for this lecture. So in the next lecture I will be discussing proximity sensor, especially inductive and capacitive type, although there are many, but yes, I will have to stick with this in view of time and your syllabus. But yes, these are the most common one which are there in the industry, so that I will be discussing. So this is inductive and capacitance based sensor, and other very prime thing which is there to do robotic manipulation, sometimes compliant manipulation, sometimes cobot they use, force and torque sensor. This is one very big class of sensor which is there. So that I will be doing in the next class. That's all. Thanks a lot.